I did not. I offered. Good? All right, cool. All right, hi everyone. Again, Paul Jones. Sorry to introduce myself. Good news, they found a way to keep me on time to these presentations. Finally, there's a presentation I'm not late for. It just made me be here for all of them. Okay, so I'm going to talk about the PropDef syntax. To resolve some ambiguity, you may have heard talking about the prop syntax or the props syntax. They were probably talking about this. I'm trying to beat over to the head of all the developers. We should call it this because there is actually 2 syntaxes that use the word props. But this is the only one that deals with PropDef, so we're calling it PropDef syntax. Okay, so what is the intention of the PropDef syntax? So prop objects and PropDefs are becoming increasingly important, especially PropDefs, right? They have, of course, they're normally just standalone. We're breaking statically typed, strictly typed use cases. But vessels and components are also being handled and communicated with via prop object interfaces by PropDefs. Core properties are built off of PropDefs. Prop schemes is also going off of PropDefs. In a way, prop schemes are kind of an extension of core properties, but point is, we're going to be making these prop objects and these PropDefs all the time. They're going to become very, very important. So we need a really fast and efficient way to create all these PropDefs. So right now we've got append PropDefs. Right, it's fine. You can treat it like you normally treat OO in our language. But then you also have like an input setting method, a domain method, put and get. There's a lot of stuff that you would probably want to override as well if you're going to do that super manual way. The PropDef syntax can make all of this a lot easier. Documentation. We actually have some. For once, we actually have documentation on some. Thank you. Thank you. It was hard for us, all right? We're trying. But we actually have documentation on this one, and it's actually good documentation. I mean, really just to knock it out of the park. It's on our wiki under append PropDefs, and it's actually pretty awesome. CJ wrote most of this, and he's been, for the most part, maintaining it. It does need a couple tweaks, but it's got a lot of good stuff in there. It covers not just this syntax I'm going to go over, but also how you would do it if you were calling append PropDefs yourself. A lot of times it does like a side-by-side. If you're using syntax, do this. If you're using append PropDefs, do this. Oh, and if for those of you with a photographic memory, there's the URL. We're going to try and make this a standard. We're going to try and do this with more of our newer things. But we got to start someplace, so here we are. Okay. Right, so I guess let's get started. It starts with this. Props block, or the PropDefs block. Never mind that it says public, implying that you could call it private or package. You can't. It has to be public. Sorry. This is basically just for syntax resolution. You need to be there in order for us to recognize what you're trying to do. Don't do anything other than private or package. I think it'll compile, but it's probably not going to do what you want it to do. This can only occur once per class. Well, that's because the way the syntax works is it actually expands out to 2 different method overrides. It is actually overriding internal append PropDefs and internal INIT PropDefs. Those are 2 methods that you would normally never use yourself. In fact, you should never use them yourself. This will expand out to override them. And if you use this block multiple times, it's going to override it multiple times, and you get drama. Also note, we don't really have an established code convention for where this should go yet. I've seen some developers who like to put it underneath their fields because it kind of looks like you're setting up fields. Others like to put it around the rest of their PropDef methods because it's creating PropDefs. So do whatever makes sense to you. We don't really have a standard yet. I'm actually on the fence. I was originally putting them underneath fields, but now it is methods. It's creating methods, so we should go with the methods. But also not meth. I don't know. I don't know. Do what you like. Be you. All right, so we'll start with some. Those are the easiest. So all we're doing is just adding. Wait, to use a laser pointer. Yeah, I just added in some props here. The keys for the props. Now, that is important to know. I'm not directly referencing the name of the fields. These strings that you're going to see inside the prop syntax, these are defining the PropDef syntax, are the keys for the PropDefs you're creating. Yeah. Now, in this particular case, because I haven't defined a type, because I haven't added any other decorators to these things, the system will interpret these as being field PropDefs. And if I don't do anything else, it's going to assume that the key is also the field name it's creating a PropDef for. So there's a whole lot of assumptions being made all around, but long story short, if you have it set up like this, it's going to create a field PropDef, and it's going to point to a field with the same name. If you were to do this by hand, append PropDefs would look like this. So already you can see how much time we're saving just doing a simple field PropDef case. So with field PropDefs specifically, well, I mean, caching PropDefs is a good idea for all of your PropDefs, but with field PropDefs, it's especially important. So the first time you use a field PropDef, it actually has to hit the runtime, right, and resolve what class are we talking about, what field are you looking at, what's the memory offset of that field. It has to do all this stuff. After the first case, it does cache that stuff so that repeated uses of the same field PropDef are optimized, but that, of course, all gets thrown away if you regenerate your PropDefs, right? So caching your PropDefs, especially with field PropDefs, is really important, and so that's made easy too. So the only thing different between this and what we just saw is that I've added this colon there, and then these arguments cached equals true. That's all it takes. Now those PropDefs are cached. And again, beneath it, you can see what it would look like if you were doing it manually. I'm not going to do this for all the stuff I talk about. I'm only going to do it for a handful. I really just want to get the idea across that you are saving a ton of time by using the syntax once you've learned it. Yeah, there's just a learning curve. That's why you're here. But once you learn it, it saves a lot of time.
Can you mix them up or no?
Mix them up? Yes, you can. You can, because the syntax, the PropDef syntax is overriding the method internal append PropDefs. This is append PropDefs. The system actually calls both. So you can't have these in the same class. In fact, sometimes it's necessary. Yeah. I'm going to call these guys, basically anything that I'm using to qualify a PropDef, I'm going to call these arguments. Or I might slip a tongue and call it decorator from now and then, but it's the term we're calling them is arguments. I also want to talk about scope for a quick second. Props creates a scope. Most decorators can be most arguments can be applied to a scope. What that does is it means the arguments that you apply to the scope implicitly apply to everything within the scope. So instead of actually saying cache equals true for every single PropDef, I'm just putting it on the scope, the prop scope, so that makes it apply to everything within the scope. So now all of those guys are cached. Note that if you have nesting scopes, which we'll see in a couple slides how you can create further scopes, arguments are resolved from closest to the PropDef working its way out. So I can do this. So here on that particular field PROPDEF H, I'm saying cache equals false, which is overriding that cache equals true because it's closer to PROPDEF. You can, let me brain for a second. Yes, you can put in code here that will, well, you don't have to put in hard-coded values true and false. What I often do, specifically with caching, is I'll put in not develop mode, like pound develop mode, because caching them while you're developing can get you burned, but you want it cached at runtime or release time. What? So it would be cached equals not develop mode. That flag is resolved at the time you compile. Yes, the time you compile. Hey. So creating some scopes. The keyword defs, like here, is just creating a new scope. So in the top example, this is completely pointless. I haven't applied any arguments to the scope, so it doesn't do anything different. The output will be the exact same as not having the scope. But because it is a scope, I can apply arguments to it, like you see in the bottom example. So now D and H will both be cached, W won't. So we've been talking about field PROPDEFs this whole time. What if you don't want your PROPDEFS key to match the field name? Well, then you just tell it what field name you want. Easy peasy. Now, I don't think I have an example in my slides, so I'm gonna try explaining. Yeah, here we go. If you want to have multiple arguments, it's just comma separated. I don't know, whatever. Then you just have as many arguments as you want. Oops. Gesundheit. All right, so we've been using field PROPDEFs this whole time, but they aren't the only PROPDEFs. So we have what I'm going to call base PROPDEFs. I don't want to just call them PROPDEFs, but that's what they are. This is just creating, like actually PROPDEFs, like it is the class PROPDEF, the base PROPDEF type. For those of you who haven't actually looked at the class before, the base PROPDEF class, I mean, it is usable. Just all it does is basically redirects to prop data and back again. So by itself, not that useful. This right here, in fact, is barely different than just letting these keys be anonymous prop data. Does everyone know what I mean by anonymous prop data? Or better question, does anyone not? Okay, so real quick, on prop objects, there's multiple ways to handle where data goes when you put to values, right? If you have a PropDef in place, PropDef sort of takes control and says, I'm going to take care of how get and put work. If you don't have a PropDef in place, it's what's called anonymous data. It just gets shoved into a string to object map and pulled back again when you call a get. So what this is doing, it is actually creating a couple of PropDef objects, but because the base PropDef class doesn't really do anything apart from just redirecting your prop data, this doesn't really change your situation. All this has done is you can now say, I have a PropDef for that key. Doesn't do anything different, but I have it. So this might be relevant to if you're invoking like push props or something, which depends on having a PropDef. Where PropDefs become, the base PropDef class becomes more useful is when you start adding arguments to it. So again, for those of you who haven't seen the PropDef class, you can add certain arguments to it to indicate how it gets stored and saved and streamed or whatnot. So here I'm saying that this isCube is stream null. So whenever this object gets saved out, that value in the prop data is just going to get nuked. Copy reference does what it sounds like. Whenever this object is copied, this value in prop data is not like deep copied, it's just a reference copy. But again, the base PropDef class is not super interesting. Field PropDefs are great, and then custom PropDefs are really where it's at. Like if you desperately need a PropDef that returns a random number, like I do on a daily basis, this is the syntax for using your own PropDefs. So this is under the assumption that you have like written your own PropDef. You got a separate file or whatever with a class in it called, in this case, ran PropDef. Everything is defined in there, and you just want to use it, but in the PropDef syntax. This is what it looks like. So again, it's just the key, the type, and then colon, the type you want to extend. Well, in this case, not extend, just use. One limitation to this is that your PropDef's constructors need to match like the core version. So in this case, I'm not field PropDef. This ran PropDef's constructor needs to match the PropDef constructor, because the syntax is really just expanding out to calling a new ran PropDef and then dropping in arguments. So when it doesn't compile, because the compilers or constructors don't match, now you know why. If you want to use a specific type of PropDef as well as apply arguments, this gets a little bit weird, but you have two sets of colons now. The type comes first, and then your arguments. What really makes this laser pointer fun is the fact that I'm pointing to all this stuff so you guys can understand what I'm talking about, but the people who watch these videos later will have no idea what's going on. Okay, so yeah, you can write your own PropDefs, and you can write them by hand. Is there a question? Okay. But thankfully, the PropDef syntax makes that way easier so that you don't actually have to do that anymore. Have to. You can actually override it in the syntax. This, in my mind, is the best feature of the PropDef syntax. I don't need to create a new file, create a new PropDef class, and then tie it to my code somehow. I can just, in place, where I'm using the PropDef, say, I want Git to work this way. It's about as easy as it gets. Nah, easy gets. Yeah, funny. Planned it. Scripted. No. Yeah. Yeah, it does.
Me and Caleb actually started a very specific commenting way so that you could read these.
I put this as like a ridiculous example, but yeah, it can. And we're only talking about putting Git. Once we start talking about core properties, then you have label and domain and setting and all these other things you could override as well. So your single PropDef could get to be 50 lines long. But this doesn't really happen that often. If you are implementing a PropDef and it's pointing to something that's on your snapper already, you probably already have methods in place to do it. So really your PropDef is just piping to those methods. Is no one going to ask about what that is? Is no one like at all confused?
I was going to say, I was going to look and see if this works there. Apparently.
Well, yeah. Huh?
But I noticed that, at least when I was doing it, if you throw a method function that gets called before the field change got changed. Is there a way to do it so that I can have the field change and then the method get called so that it doesn't correct that?
Oh, I see what you're saying. Yes, there is. Hang on that for half a second, because I got 100 people asking me what that means. I mean, I got they're you hear them? Like, can you hear them? All of them arguing over what is that? Thank you. Keep in mind that this is all about defining a PropDef, right? So this would be the PropDef, right? So this doesn't work anymore. So you have that. That is a reference to your owner, right? So the guy who owns a PropDef, but cast as the appropriate type already. So if this code was inside of the demo box class, that would be a reference to owner cast as a demo box. This is how it just makes it easier to refer back to stuff that's actually still in your class and whatnot. So back to your question though, the overrides. If you're overriding a field PropDef and you want some kind of a post change notify kind of a thing, you might want to switch to using prop changed. You can do what you're doing, but what's that? Okay. Yes. No. Yes. Kind of. Prop change is like that's what it's intended for. So if you want to stick to strict intentions of what things mean, that's where it goes. But you could just call super first, right? Or you could just not use the field PropDef. You'd have to do it for everyone then. Anyway. Set the field and then call something, or call something and set the field. Yeah. So I would just call super, do your thing, return. In here. You can call super in here, yeah. These are method overrides. So what's actually happening is right here, it's actually, don't be scared, it's creating a new anonymous class, overriding these methods, and dropping in your code as well as super into the get method of this class that it creates. So if you call super first, it'll do its thing, your code, return, it'll never hit that final super, won't push the value again. And then, yeah, you have what you want. That is sort of a hidden behavior that's not super publicized with this. You are overriding methods on PropDef, and it will still call super unless you return, unless you don't let it. Ignore super equals false. That's bullshit. I found out I was using this wrong. In this case, I'm overriding get input, yes. So it's super. Just this one. Oh, just the specific get. Okay. Yes. Yeah. So it is called like implicitly, but you can also call it explicitly. If you call it implicitly, it does not take it out. It's still going to call it again. Yeah. That's why be sure to return afterwards. In fact, that means this code right here is wrong. Because this is going to, the way I have it written now, it's going to call the set material, and then it's going to put it to my anonymous data as well. Damn it. Damn it, damn it, damn it. Okay, moving on now. So in this case, I have a specific, like for this material PropDef, I've got a specific way I want to handle it. I call get material and set material. But maybe I've got a bunch of props that are going to have something that's in common between all of them. Say dimensions. They'll have the same domain because it's, in this case, it's a block. Dimensions are all the same. You have this methods keyword. Methods is a block dedicated to override methods, in this case for all of the keys, in the same scope. So in this case, I'm overriding domain for W, D, and H. Correct. It's in the same scope, specifically. So, like for this, for example, see, I know what I'm doing. So D and H now have their domain methods overridden, W does not. Domain, if you're not doing core properties, I don't think actually even matters, but it'll matter when you do core properties. It does. The base PropDef class has these methods on it. So you can't override made-up methods. So another way of doing this, I think this is the easiest way to understand it, but you can also do this. Instead of just saying methods, applying this to everything in the same syntax, scope, I can call it specifically which keys this is going to apply to. Oh, something I forgot to mention. The def scope, we actually do have a recommendation you do not nest them. There's no coding reason why you can't. Like, it handles it just fine, but it does get real hard to read real quick. I mean, already we've got a little bit of nesting. It's getting a little bit of, well, what does that method apply to? You know? Actually, I forgot. Before I make the next leap, does anyone have a question? Like, just about stuff so far. I'm about to kind of shift in a different direction, so I want to make sure. Anyone? Questions? We're all good? We all know how all the PropDef syntaxes work? Okay. Now I'm going to get a little bit weird. The construct block. This is, so the PropDef syntax is actually creating code. It's creating overrides for internal append PropDefs and internal init PropDefs. The construct block has a very specific usage. Whatever code you drop inside the construct block is dropped into the beginning of internal init or internal append PropDefs. It doesn't parse it. It doesn't do any kind of a syntax searching. It's just dropping this code into the beginning of the method. That's handy because then you can start referencing things you set up in this block elsewhere. So here you can see I made a little domain here, a double enum domain. I called it DOM. And then further on in the syntax, I just start using it. Which is when it actually expands out, it's going to look something like you're seeing down here. Then, in addition to the construct block, you have the init block. This is code that gets dropped into the internal init PropDefs. This is code that you use to initialize your PropDefs. So they've already been created. You've probably already set up your domains and stuff, but maybe you need to do something that requires a bit more intelligence than the syntax allows. So that's what this init block is for. So in this case, what I'm doing is I'm checking to see if my dimension is above or less than 40 inches, then my depth domain should actually be this. Construct blocks and init blocks, you can toss them in wherever you want. You can even have multiple within the same syntax, but it's not going to make a big difference. It's still just going to, toss them into the relevant methods. They'll be in order, but there's no like scoping applied to them. So, that's different. Which is probably not a good choice on our part, but yeah. But no, you can't use the construct block outside of. This is no link, so I never actually tried, but I'm pretty sure no. Okay. So not that we would ever need to debug our PropDef syntaxes because we're all masters at this point, but if theoretically you did, we have a couple of arguments you can apply to the PropDef syntax itself to get some help. First is just help. So you add this help equals true argument to your PropDef syntax, and you get this output that you see down here. Is this too small? Can everyone see this? It's reasonable well? Cool. It just has like a reference to the wiki, which again is awesome. You should definitely check it out. And then some quick tips for like getting started with the PropDef syntax. It's not exactly debugging, but I guess it's help. What's more interesting is debug. So debug equals true. This is going to dump out basically what the syntax did. it's going to dump out which PROPDEFS that it created. In this case, it's telling me that they're cached. If I was overriding, like making my own methods, whatnot, it would also tell me the type it created as well as what type it's extended from. But the next one is by far the best debug tool, and that is full debug. This actually dumps out everything that the syntax is actually doing. So at compile time, so you throw this in there, you hit compile, it'll throw this into your compiler. This is what it's going to toss into your method, internal append PROPDEFS. So there's nothing secret about it. There's no magic to it. So which one was I doing? This. Okay, this is like the original just field PROPDEFS WDH with caching thrown in. Oh, and the DOM thing, yeah. Yeah, so this is also really helpful. It also keeps us honest, is probably why I personally like it. We'll never let the PropDef syntax do something you can't do yourself, because it's a requirement that the PropDef syntax expand out to code, right? Code that we can read and understand. So. It is just a compile time thing. Every time you compile, actually. Nope. It's just a key that's sent to like the syntax expansion. I don't know if you know, the syntaxes in our language are basically macros. But at the time of expansion, we also do a massive print line of what we expanded to. That's all. And in good time, that's what I got. Anyone have any questions on PropDef syntax? Why we should use them, what they're for?
That wiki's pretty up to date, or is that just?
It is pretty up to date, yes. That is accurate. There's only a couple details that are off, and they really don't even matter. So yeah, it's good.
Do you suggest any inline comments at all?
Inline comments?
Yeah, because I see that they have 3 fields in there. Right?
Yeah.
What about if I have tons of things I put in there? How do you, suggest that you make it I have more
So, right. So the question was, if you have like a bunch of props in there, is it better to have comments? It's no different than anything else, like with your fields in your code that gets too long. Consider that most field PropDefs are pointing to an actual field, which has their own comment block, right? So field PropDefs, they're kind of already documented. For the PropDefs you're making that are like,
I just wondered that because it could be very messy if you're not careful how you structure it.
Could. We don't really have a code convention in place, in like saying when you should and shouldn't comment this. I would say just use your best judgment for now. If it is getting too hard to read, then yeah, maybe you do need to start indicating what these are for. I haven't seen it be a problem yet, but it's a good thing to think about, yeah. Any other questions?
You said the construct and init, you can just put in wherever. Does it put it in the corresponding place in the internal PropDef?
It will place it in the order it's encountered. Okay. So like scanning your PropDef syntax from top to bottom, that's the order it'll drop them in there. But scoping doesn't do anything to it. Anything else? Questions? What's that? CJ. Or at least mostly CJ. I think you did work with Euron a little bit, but mostly CJ. PropDef syntax is going to make core properties quite a bit easier as well. You can do without it, but it just makes it so much easier. But you're going to talk about that stuff in the next section. Okay. Yeah. I mean, everyone. I really, really strongly encourage you to start playing around with PropDef syntax. It is a bit of a new thing. It doesn't work like the rest of our code does, but it makes PropDefs so much easier. And because it's becoming so important going forward, it's really a valuable skill to beef up. And if you have any questions, as always, shoot me a message. Forums, dev support if you're especially angry, I guess. Or if you're especially angry, I could get you CJ's address. I don't know. But yeah, thank you, everyone. What's that? The other prop syntax? Mind stopping recording first.